All right, my beloved sixth period. Today we're going to be doing a combination of working with integers, working with the coordinate plane, and also with with relationship between 2 points. How are they related to each other? And when you have 2 points and you draw a line between them, it's going to create what this title is called, or this section is called, which is slope. So naturally, my name is Ski Slope. All right. Does everybody have, before we begin, does everybody have the copy of the notes? Yeah. Wonderful. So when we're looking at a graph, we call the steepness of the line its slope. It is the steepness of the line is its slope. And when we label the slope, we label it with the letter M, as in make money, Mark. Make money, Mark. Yes, sir. There's certain designations that algebra is assigned to recognizable variables. So, well, algebra just says, hey, this letter here, let's have that be recognized as this in this situation. Okay? And that's the extent of it. I don't know the specifics, but they just decided, let's use M. And somebody else is like, fantastic. Okay? Maybe because the M has a slope in and of itself, like there's so many different ones. I don't know. Okay. Yeah. All right. Vertical change in a slope is called change in y. And you're going to see it as being delta y. Delta y, it's actually a triangle. Okay. Change in, that means one thing minus another. So difference of distance or difference. So one thing minus another. Then we have the horizontal change. And in our graphs, horizontal, the ones that are measured left and right, that is the x-axis. So naturally, this one's going to be change in x. And that's going to be delta x. And algebraically, remember that x's have that little kind of tail on the side, so you don't think it's a multiplication symbol. I'll zoom in a little bit for you guys to see. And when we find slope, or M, we use the following formula. M equals change in y over change in x. I did it again. There. Y. Change in y over change in x, or to put it nice and small so you can rewrite it as often as you need to on the homework, M equals change in y over change in x. Now, I lost focus for a minute during fourth period, and I accidentally put the change in x there when we were working it out, so make sure that you're keeping the y's on top. Now, this kind of goes against what we've been saying lately, because usually it's in alphabetical order with the coordinate plane and all that stuff. But this one is y on top. X bottom. So finding the slope. There's 2 different ways I'm going to teach you how to do this. One of them is by looking at a graph and being like, okay, we're traveling this far, so that'll be it. The next one is going to be mathematically. So let's go into the visual way of doing this first. Okay? So we have a graph here. The first thing that we're going to do, whoops, come on, Scott, there you go. The first thing that we're going to do when we see these, there are 3 questions like this on the homework assignment. We are going to put a star here, and I want you to write this. Find points on line that go perfectly through intersection. And it says intersection because what happens when 2 roads meet? Intersection. Beautiful. And then with this situation, the intersection is going to be where our line lines up with one of the numbers on the number lines. And what I mean by that is, looks like we have several spots that we could choose from in here. See how the x-axis and the y-axis meet perfectly with the line in those spots. This one is kind of convenient, but that's an example of how many different spots that we could choose. So someone tell me one of the spots that matches through there perfectly. Austin? Positive 2. Okay, so positive 2. So we're talking about the x, and then what's the y value of that? 4. Yeah, 4. Because that's where the line is going. That's what we're finding out the slope of that line. Yes, sir? Okay, what's the next one, sir? -1, 3 would be right here, and there's nothing on. Yeah. There we go. -1, or -3, -1 is what he meant. So we have 2 points here, and I'm going to zoom in on this just to make sure that if fourth period is watching this, they can see exactly what they saw this morning. So I need to see how these two, where they are from each other. So remember, the change in x is how far x goes. The change in y is how far the y values go. So I'm going to choose pink. Perfect. How much does y change? What? Here's a y value for one of our points. Here's a y value for another one of our points. Do you agree that this guy is at, Do you agree that this guy is at that y and this guy is at this y? Okay, how much does it change going from one to the other? Moss? 5, because he counted 5. 1, 2, 3, 4, 5. So our change in y is equal to 5. Our change in y is equal to 5. Yes? No, go ahead. -3, 1? -3, -1. Do you agree that this line that we are talking about goes through -3, -1? Okay. We need to pick 2 lines, as it says right here. Find points on line that go perfectly through the intersection. Here's an intersection right here. Does a line go through it? No. Here's an intersection right here. Does a line go through it? No. We wanted to choose a line, as it says right here. We wanted to choose a spot on the line where it goes through an intersection point, and this one does. Yep. -1 and 1. -1 and 1? Yeah, we could use this. We could have used this. We could use this. We could use this. This keeps going. We could use that one. The arrow just stops. The arrow keeps going on forever. We just stopped it there. Eric. I'll show you, actually. I'll show you. So we have our change in y is 5. Oops, I didn't have that big color. So we're getting back to that one. All right, we had our change in y of 5. So we went from this guy to 1, 2, 3, 4, 5. That is our y value of those 2 points in blue, the change in them, how far you would have to travel if you were going. So here's another way to look at it. I'm going 1, 2, 3, 4, 5 on the y. Here's my y-axis, and I'd be high enough on the number line to be on the same level as that one. So this guy's like get on my level. What is 2, 3, 4, 5? 1, 2, 3, 4, 5. No, it's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The other way?
Yeah, not like the one that needs to go across the X.
Oh, let's do x. We haven't done that one yet. How much does x change? So now we know that it took us 5 blocks to get up there, 5 units to get up there. And now we have to see how far this value of x right here is from this value of x. So to do that, I'm going to travel 1, 2, 3, 4, 5. So it's delta, change in x is 5. Are you just seeing it differently, or do you want me to show you again? If you're having trouble with the visualization of it, I highly suggest you go straight on the x-axis of where you were, and you just 1, 2, 3, 4, 5. Now I'm lined up with where the other x is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now we have to add it into the formula, which is m equals delta y over delta x, which equals, what's delta y? What's our change in y? 5. What's our change in x? 5. 5 over 5 is equal to 1. Now, whenever you're doing an improper fraction, leave it improper. Okay? You don't have to put it into a mixed number. Like the homework assignment, one of them, you're going to get an improper fraction tonight. So just leave it as an improper fraction. Yes? The next day, I see you, silly.
But you'll see me too.
So that is the way to visually represent it. Now let's take it more. This time we see these 2 points. Okay, this one's going to be visual again. So they gave us the 2 points. We're at -2 and 5. So I'm going to go -2. -1, -2, and 5. 1, 2, 3, 4, 5. So there's 1 point. Then I have 4, -5. So 4, -5. This is what we've been doing the last 2 weeks. Okay, that's why I'm just zipping through that coordinate plane. Okay, when you guys made these and stuff. Okay. Then I'm going to take my school-issued straight edge, my ID that I'm wearing right now, and I'm going to draw a line through these points. I'm going to change the color and the thickness. There and there. All right, stick with me. I don't have candy that I can distribute. That'd be nice, wouldn't it? That'd be a really good reward. No. So now we are going to find how far those things are from each other. And by finding how far they are from each other, we are finding the slope. So we are going to have our slope is equal to change in y over change in x. I'm just rewriting that because I need to remember that it's y over x. Yes, ma'am? It's a delta. Stop making fun of my handwriting. Thank you. See, you got. So the way that we just did that before was we looked at how far you had to go in one direction. Now when we are going from our y values, which is going to be the top and bottom, so it's vertical, let's go from this guy. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that guy's traveling from the first dot to the second dot. He went down. Now in a number line on a y-axis, is down a positive movement or a negative movement? Negative. So he went down -10. So my delta y is -10. That's a great question. We'll do that one next, okay? So the student just asked if why can't we go here and go that direction? I'll show you that we sure can. Next we are going to be, so we're not quite to the other dot yet. We still have to travel to the other dot. So now I'm going to go on the y-axis. I'm going to go positive. 1, 2, 3, 4, 5, 6. So my change that I moved on the x-axis is a positive 6. and I get to be negative 5/3. The slope is negative 5/3. The slope is negative 5/3. Good. Yes, sir?
So is the change in y always the numerator?
The change in y is always the numerator, and that's why I'm making you guys write it this many times. Yes, sir?
Do we put it into a mixed number, or do we keep it in an improper fraction?
Who remembers what I said about a minute ago? What is it? Keep it improper. All right. Now, Olivia asked me, what if we wanted to go from, let's say this is point A, and this is point B. We just traveled from A to B. What if we want to travel from B to A? Question, Katie?
Yeah, I don't know if you already answered this, but I'm confused on why the 3 is so negative.
Why the 3 is not a negative?
No, it's because
Yeah, I just reduced it. Good answer. Okay, so now we're going to travel from this guy and to go up. You don't have to erase what I just erased. I'm just going to show you the other way of looking at this. You don't have to do it like this if you don't want to. So I'm going to start from that guy and go up. So I'm going to look at my change in, what do you want to look at first? The change in y first or the change in x first? You want to look at the change in x? Okay, so that means that I'm going to be going left or right. Now I'm starting at this point and I'm going to be going a negative 1, 2, 3, 4, 5, 6. So my delta y, or my delta x is negative 6.
so it never matters.
Then I went negative on the x. Now I'm going to go positive because it's going up. When your grade goes up, it's positive. On the number line of y, when it goes up, it's being more positive. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a positive 10. And when I reduce this number still, it does come out to be like that. Cool? Alex? Yep, that's exactly, oh, well, yeah, you're going to get the same one. It's still going up, positive 10 on y, and negative 6 on x, across the x-axis. Yes, sir?
So why wouldn't it just be 5 over -3?
5 over negative 3? Usually, to avoid confusion, you put the negative with the first part of the fraction you're going to see. Yeah, it's still negative either way. Yep. The only time you'll see it where it's in the denominator is like a test or something like that on number sense. Yes, sir?
So should you always start with like the bottom plate, like count?
You can start with whatever one you want to. It'll be more clear when we do it mathematically, and we're about to do that next. Okay? Here, sit up here. Sit up here. Because I'm going to break your temptation. I'm going to break your temptation to do anything other than follow along. And then you, sir, move to your desk 1 to the right. Okay? So, now we have this one. That is very zoomed in. Next page. Sometimes we refer to vertical change as, what's it? Oh. Okay, let me get through these 3 words, and then you can ask me. We refer to it as, so vertical change. Vertical change, what's a word that we could use for vertical change? And forget about how math just uses these weird words. Yeah. Vertical change would be change in y, but it's just going to be one word. Yeah. Up. Good idea. Yes. Height. Good idea. Difference. Yes, I see, but you need 2 different things to have a difference. In our point of view, there's something that happens at dawn. Rise. The sun rises. Rise. Vertical change. And the horizontal change, what is, let's see, who's, I don't know who, Trey. When you're changing your location in space after school, not space like outer space, like space is in the area between us. After school, what are you doing after school these days? Track. And what do you do during track? Run. Vertical change, rise. Horizontal change, run. Yes. The what? What? Yeah, is that right? Yep. Yeah, this sort of thing hasn't changed in years. This isn't anything horizontal. Yep. Yes. No, it's dusk. The lines that had the same. Okay, good. I'm glad we're considering mathematics vocabulary, but let's continue with this. All right, I want to give you some time to do homework. Lines that have the same slope are parallel, naturally. Okay? Lines that have the same slope are going to be parallel. Not only are they going to be parallel, but they are parallel. Bless you. Yes? Oh, you're right. Thank you. Yes, you can. I didn't show that to you, but it'll come up in this question right here. Okay? That question will come up in that one. Good. So those that have parallel lines. Now, we've looked at it visibly. Let's do one mathematically. Actually, before I do this, does anybody have any questions about what we've done so far? Good. So we have our delta y and our delta x. Our change in y over change in x. We're going to try to find the slope of those points. Now, when we have the slope, it is the change in y. How are we going to find out how far away those two are from each other? Okay. If Trey was running in a distance race, we started at the same time. We know how far Trey has run. We know how far I have run. How are we going to find out how far ahead of me Trey is? How are we going to find out how far it is? Yes. We are going to subtract. We are going to subtract one of the distances away from the starting point from the other distance of the way of the starting point, and we'll find out how much he's smoking me by. Okay? So, because I bet you guys could run a lot longer than me. So I have 2 points here. I'm going to zoom in, please. I have 2 points here. I have -1, -3, and 1 and 3. And I'm just going to remind myself, this here is x, this here is y. This here is x, this here is y. And the change in x and y, to be able to find out how far that is, we have to subtract one from the other. We have to subtract one from the other. Okay. Okay, good. So I'm going to take my change in y. I'm going to subtract 3 from -3. 3 minus, we have -3 minus 3. That's my change in y. My change in x is going to be -1 minus 1. -1 minus 1. Here's those integers coming back at us. So -3 minus 3 is -6. -1 minus 1 is -2. And since that comes out to be a whole number, I'm just going to say that slope is 3. Slope is 3 from this point on a graph to this point on a graph. That's what we're finding out. And our next step is to find out what the slope is of these 2 points, because we want to see, are they parallel? We're trying to find out if those are 2 points that are parallel. So all you need to find out what the slope of a line is 2 points. Or in order to make a line, all you need is 2 points. Like if you're ever building a fence or something like that, you want to make sure it's straight. All you have to do is put one stick in the ground here, one stick in the ground here. All the other sticks that are between them will be in a straight line. Yes?
So pretty much
Because I know that, okay, all right, I see what you're saying. Let's not skip steps. So then we have -3 over -1. which is equal to 3 over 1, which is equal to 3. Yeah. Eric? Yes. Okay, so m is 3. Now let's find out the slope, mathematically, of this line to see if it's going to be parallel. Because if it's parallel, that means that both the slopes are the same. Yes, sir? Okay, so want to help me get started? Okay, what's the first thing I need to do? Beautiful. Change in y over change in x so I don't make any silly mistakes is equal to 0 minus 3, because here's my y, and I need to subtract it from the other y. So 0 minus 3. Beautiful. Then, actually, why don't you just carry me through? What's the next thing I need to do? 2 minus 3, because here's my first point of x minus my second point of x. 0 minus 3, negative 3. 2 minus 3, negative 1. Oh boy, oh boy, oh boy. Are those 2 points parallel, ladies and gentlemen?
Yes, sir.
Why are they parallel? Good, because they have the same slope. There's 2 ways of doing it. You can look at a graph. Like, 4th period loved the visual, and the mathematical came around to them. And 5th period liked the mathematical. So it's what I'm showing you both ways, so you can have multiple ways of doing it. Mathematical does seem easier, but everybody learns a little bit different. Mathematical seems different. Now, here is one that this is the majority of your homework, just like this. Okay? Just like this. So we're going to do it mathematically. Now, earlier Eric asked me, can we please choose any point on those lines? The only requirement is, as long as it is a point where there's perfect intersection points where the line goes through. We could use any point. Like if I were to go, see how this guy right here is not a nice intersection point? Can you see that okay? Yeah. Okay, if I were to go right here, and I could get that to the exact point that it would be a decimal, it would still work. It would still work with the same slope, finding a difference between that point, but I don't want to mess with that because I want to be able to see it. Because if it's not exact, it won't work. Yes, sir? It does say slop. Good. See? Paying attention. So, instead of finding the slop, let's find the slope. Is that a deal? Okay, we'll find the slop later. Josh, notice. All right, so here's A. We're going to find A. Here's the line A. So we're going to find the slope of line A. When we're looking at this, there's a couple of different ones that look like they might have a perfect intersection. Okay? So we have a couple that could be going straight through. Here looks like one. Let's see. Negative 3 and negative 4 possibly. Here's one possibly. Here's one possibly. Maybe that one. So, those are all the points. One of those I just gave, what are the coordinates of one of them?
Oh,
Can,
negative 1, 3.
Sure.
If it's down the middle line, the gold line in the middle, would that count towards any one?
Like this?
Yeah, that line.
That would be a vertical line, so there would not be any change in x. So that's how it would go. We'll have an example like that in a little bit, actually. All right. So we have 1 and 3, so we're keeping this guy. Oh, that's not the one I had. Negative 1 and 3, thank you. Okay, which one did you want to use, JT? 0 and 1. 0, 1. Okay? Those are the 2 we chose to use. Those are the 2 we chose to use. So let's find our 0, 1. Let's find our slope here. We're going to find the change in y over the change in x. To do that, we do the first value of y minus the second value of y. Here's the first one. Here's the second one. Then we have the change in x. The first value of x, -1, minus the second value of x, 1. So we have 2 over -2. No. -1 minus 1. -2. Ah, there we go. Thank you. That shouldn't work. Okay. 0. Thanks. So we have -2 divided by -1, which means that our slope is -2. Our slope is -2. That's just like this is the majority of it. Let's do another example. Good. I love hearing that. It's going to be just like this, though. That's the thing. I want you to remember that how many of you just said this is easy, because it should be the same comprehension level, because I promise you there's going to be a section just like this on the test. Anxiety. Anxiety is a lot of reason why people don't do so well as they will at this. Joe.
Can you scroll up just a little bit, because I just really get all
That? Yeah, I'll give you a couple seconds. We got to get going. Is that a hand up? Yes, sir. Let's do... Yeah. No, let's we're going to Smith this one. We're going to Smith B. Can you still give us a coordinate for C? Or okay, 2, -3. I'm going to change color so people can see what's going on. We have, hey, quiet please. We just got 9 minutes, so I want to use them all, okay? We have to use them all, that is. So what was that again? I got lost because the boys were talking. 2, -3. So 2, -3. Oops. Yes. 2, -3. And what's another point on there, Ensley? 4, -2. Cool. So I have 4, -2. We're looking at part C. My change, let's see here. We got 2, -3, and 4, -2. -3, 4, -2. So my change in y over change in x, we have -3 minus -2 over 2 minus 4. That comes out to be -3 plus 4 is 1. 2 minus 4 is -2. So I have my slope is -1/2 for this guy.
So how's it 1/2? Oh.
And I'm going to show you visibly how it matches up the same way once you guys get done recording that. Yes, sir?
-3 plus 2 is -1.
-3 plus 2 is -1. Yes. And -1 over -2 is 1/2. Yes, ma'am. So we found that it's a positive 1/2. Now let's look at this for those visual learners. We just found that the slope of this guy is 1/2. So I'm going to go with my rise and run version that we did with the bouncing arcs. How much does this go up before I'm at the different level? Just 1. Boom. So my change in y is 1, and it goes boom, boom, 2. My change in x is 2. And these are the same. But you always won't have a graph to look at. So the purple that I just did is the visual way of doing it. The orange here is the mathematical way of doing it. While some people like the purple version, you always won't be able to see the map. Yes, you can create a map or create a graph of it if you like that way better, especially for those of you who are not so great at integers. However, that means you need to draw a lot of maps up, and I need to be able to see it. Austin. That's what I just explained.
I know, but like
As long as you can, as long as I see a visual representation of it on a graph, fine, that's cool. Because you'll know that you're rising up 1 or 2, or over 2, or whatever it might be. All right, let's do, how much time we have left? Ugh, no. We're going to have to smith this one as well. All right, let's do another couple of them with mathematically. No. So we got change in y over change in x. We're going to take, stop. We're going to take our x values, subtract the first one from the second one. We're going to take our y values, subtract the first one from the second one. So we have 4 minus 6 over 3 minus 4, negative 2, negative 1. The slope of that guy is 2. That's right. Because when you divide a negative by a negative, you get a positive. Why would D be on top? Here's watch. Here's C. 3, 4 is, hey guys, stay quiet. 3, 4 is C. 4, 6 is D. What's confusing you is you're seeing a common number. That's what's confusing you. See how there's a 4 here and a 4 here? That's just coincidental. Okay? Yeah, Joe pick.
why is 2 not negative 2? Because
A negative multiplied by negative is a positive. Okay, how about a C and D?
A fraction is division. Yeah.
Why did 3 minus 4 equals -1 and 4 minus 6 on the bottom?
You just said 3 minus 6. There's no 3 minus 6.
Well, I have to see the top.
There's no 3 minus 6.
3 minus 4. I had these I had 3 minus 4 on top and 4 minus 6 on the bottom.
I even have them highlighted color-coded right now. See how I have the blue? Look where the blue is. Blue is all the Y's. Okay.
Oh, yeah, because it. Because why? Yeah, because it's something we learned the other day. I didn't learn it early.
As part, well, it was until a second ago. Okay. Write this. I need to complete this one, okay? This one we can smith, but I want to do number 4. Okay. We have a change in y over a change in x on this guy. Our y's are going from 1 to negative 1. Our x's are going from 3/4 to 3/4. On the top, I'm going to have 2. On the bottom, I'm going to have 0. Can't divide by 0. Therefore, vertical line. It's a vertical line. Because if the x's don't change, but the y values can be anything, that means that it's going to go up and down. Straight up and down.
So what's the answer?
Vertical line. The correct answer is vertical line on that one.
Oh, we don't put.
So what's the answer?
Vertical line is the correct answer. Vertical line. Not just the line, a vertical line. All these are lines that we're doing.
Well, I mean,
What? No, this is your answer right here, a vertical line. Any value of x is the same. So it would look like this. Your line would look like this. Something like that. I will pass out the homework now.